Hello and welcome to this webinar. Today we wanted to take you through what makes a good data analyst. My name is Astrid Cook and I'm an analyst here at version 1. So what makes a good data analyst? Version 1 has a blog called What Makes a Good Data Analyst, and we give 8 pointers a good analyst should strive to develop. And we've listed those here. So you start by telling a simple and engaging story, focus on the details. Attention to detail can help you find problems in the data, but it can also reveal fascinating insights about the data. You want to be able to understand business dynamics, be innovative with data, be personable, continuously learn from challenges, and also recognize when to stop. And here, you want to understand when you've maximized your efforts so that you avoid wasting time. So these are all good tips, good pointers. But now we need to talk about AI because AI is changing everything. And actually, we wanted to show you some very valuable tools that you can use as a data analyst. So now we're going to talk about being a data analyst in the age of AI. So how does AI help data analysts? Well, there's really 2 areas where AI can serve as an assistant. One is the automation of tasks, and the second area is machine learning. So first of all, let's talk about automation of tasks. Now, we say that 80% of a machine learning project is preparing the data for analysis. And of course, you will want to carefully examine your data, understand your data, take the steps to cleanse it, and then do the data preparation steps. And of course, these do consume a significant portion of time. But we do have some tools that can help. So things like anomaly detection. You can identify unusual cases. There are options for automated data preparation. And I've highlighted one called feature selection because I'm going to include this in the demo that I will show you in just a few minutes. But these help save time. The machine learning options. Well, data analysts can leverage machine learning algorithms that learn from the data, and these will uncover hidden patterns within data sets. And these hidden patterns yield valuable insights. So again, I'm going to show you how to uncover hidden patterns within a data set. So I mentioned automation. We have anomaly detection. Now, running an anomaly detection in IBM SPSS statistics will run cluster analysis. And then it will identify unusual cases by examining deviations from the norms within the cluster groups. It's great because you can quickly spot anomalies for data auditing during exploratory data analysis. Now, of course, you can run this. This is a real time saver, but you determine the settings and you examine the results. We have automated data preparation. This will simplify data preparation. Again, it can save time. It analyzes the data, identifies issues, filters out unhelpful fields. It will generate new attributes, and it can enhance performance with intelligent screening. But again, you would choose the settings for this, and of course, you would very carefully examine the results. Feature selection, I'll demonstrate. I just want you to know that this particular procedure you will need to get from the extensions menu. It's called Select Predictors. But what this does is it will take a set of fields or a specified set of predictor variables as inputs and selects a smaller subset for use in machine learning procedures. So it's very useful and it can be a huge time saver. Again, the analyst needs to examine this, and of course, they will examine the results from feature selection. Again, we'll use feature selection in the demonstration prior to building a machine learning model. So now let's talk about AI and machine learning. So we've been hearing a lot about AI or artificial intelligence, but AI is the broad field of computer science focused on creating machines capable of performing tasks that typically require human intelligence. Now, I mentioned previously that, of course, you as the analyst are examining, understanding, evaluating all of the results that you get. We have machine learning. Machine learning is a subset of AI involving algorithms and statistical models that enable computers to improve their performance on a task through experience. But when we think about machine learning, and machine learning in IBM SPSS statistics, you have things like decision trees or random forest or support vector machines. Of course, we have deep learning. And deep learning is a subset of machine learning based on artificial neural networks. We also have neural networks in IBM SPSS statistics. Now, with machine learning, typically when we're talking about IBM SPSS statistics, we have supervised models and unsupervised models. Supervised models, we're trying to understand an outcome or a target. So we'd like to predict who takes up a subscription delivery service. Unsupervised is where we can find patterns within our data. So there's no target to understand, no target to predict, but we're just looking for patterns in the data. So here's my challenge. Now I have information on products purchased by customers. Now this is a demo data set, but it's going to give us a good example. So they could have purchased ready-made products, frozen foods, alcohol, fresh vegetables, milk, bakery goods, fresh meat, toiletries, snacks, tinned goods. And whether or not they purchased it is indicated by a 1. So if they purchased it, we get a 1. If not, we get a 0. Now I want to analyze this data set. I want to know what customers are purchasing. I'd like to see if there's groups of customers buying certain items together. I want to find some hidden shopping patterns. And I also want to know what's associated with customers signing up for a subscription delivery service. So this is my challenge. So now we'll get started on the data. Now, very quickly, I just wanted to show you that I can automatically write the code. So you can see the code is here. So that can be time saving. And all we're doing here is just looking at purchases. And you can see I have percent purchased here. And you notice that we can see that 53% of our customers purchase ready-made foods, 44% purchase frozen foods, 39% purchase alcohol. Down here we have 10% who purchase toiletries. Only 3% purchase fresh meat. And when we look at this table, it doesn't really tell us a lot. We can see how many of our customers, the percentage of customers that buy each product, but it doesn't really tell us anything else. So here we're looking at the purchase of products by whether or not they're working. And again, this is interesting. So you can see, for example, that 55% of those who are working purchase ready-made food, 46% purchase frozen foods. Only 3% of those who are working purchase fresh meats. And we can compare those who are working versus those who are not working. It's an interesting comparison, but it doesn't really tell us anything because we want to include all of the data that we have in any analysis. So we started here with this simple table. Now I've run cluster analysis. And look what cluster analysis gave me. Now remember, cluster analysis is an unsupervised machine learning algorithm, so it's going to help me find patterns in the data. And what I found was groups of customers who are buying combinations of products. So look here, this was cluster 2. We've named it Big Shop, but you can see they purchase ready-made. So 84% purchase ready-made, 81% purchase frozen foods, 76% purchase alcohol, 90% purchase bakery goods, 74% purchase snacks, and 82% purchase tinned goods. This is cluster 2. When you look at the next cluster, which is cluster 3, we named it Food for Tonight because almost all of them purchase ready-made and 67% purchase fresh vegetables. Now, cluster 4, we labeled Convenience Shopper because over half of them purchase ready-made, but also alcohol and bakery goods. If you look at Pantry Staples, they're purchasing primarily tinned goods and just over half purchase snacks. You can also provide a graph of the clusters. But you can see what we're seeing is the combination of products that customers are buying. There is a Big Shop group. There's a Food for Tonight group. Some of our shoppers are buying pantry staples and so on. Now, the next question is, how can we use this information? Now, if I'm interested in knowing about what's associated with taking up a subscription delivery service, I can run feature selection. Now, I mentioned this, first of all, in terms of automation. So this can be a real time saver because what this does in IBM SPSS statistic is it looks at every variable that's an input to a model, and it runs a statistical test between that variable and the outcome. And it looks at the data, and it looks at how the data is typed, and it chooses the correct statistical test. So you can look here, we've got fresh vegetables. This gets a rank of 1. Ready-made gets a rank of 2. Whether or not they have children gets a rank of 3. Bakery good gets a rank of 4. And you can see here, it's choosing the statistical test. So whether or not they had children is 2 categories, yes or no. And whether or not they took up the subscription service is 2 categories, yes or no. So it chose the Pearson chi-square test. Now this is a guide. If I had 100 fields, this could narrow down the fields that I would bring into the machine learning model. But it's only a guide. Remember, you as the data analyst use your domain expertise, your knowledge of the business to determine the fields that are going to go into the machine learning model. However, this is a guide and it can save time. So I've run my cluster analysis. I've saved the results into my data set. And now I'm running a supervised machine learning algorithm called a decision tree. Remember, a supervised machine learning algorithm is focused on a target. And here I'm focused on understanding what's associated with taking up a subscription service. Now I'm showing you a small portion of the output. So you'll get a lot of output with decision trees. But have a look at the gains for nodes table. And if we look at node 24, you can think of it as Rule 24 or Group 24. These are food for tonight customers, and they primarily purchase ready-made and fresh vegetables. Now, this tree shows us that they're older than 40 or over 40, and that they're divorced, married, and single. In this group, 96%, really 97% take up the subscription service. So decision trees are great because they'll show you interactions between variables and subgroups in your data. Here's a comparison with a neural net model. Again, these are simple examples, but what you will see is that we can look at the accuracy of the model. We split the data into a training data set and a testing data set, and we can see the accuracy here in the training and the accuracy here in the testing data set. And of course, we can see the importance of the variables that we've included. Now, if you think of what we've just looked at, which is cluster analysis, and then using the cluster analysis results in the decision tree, and then running neural nets, just using the fields that we have, not with the cluster analysis, you can see we've got tools that are time saving and tools that provide us a way to use all of our data to pull insight from our data. So now, how do we use all of the information that we get from any machine learning model? Well, the models will be trained and tested on historical data. They'll generate predictions. We can save the model. Then we can apply the model that we saved to data where we don't know the outcome. And we can use this to score cases. And you would obtain predictions or likelihood of outcomes. Any insight from the model that you build can be applied back into the business. So now we want to show you how to go from a simple description of our data to using unsupervised and supervised machine learning in IBM SPSS statistics. So now I'm in IBM SPSS statistics. And to get started, I wanted to show you where things are in the tool. So SPSS is a menu-driven program. So to get started, I wanted to go to the data menu. So we mentioned automation tools. I'll click on the data menu. And down here, we have something called identify unusual cases. This is anomaly analysis. So this will help us identify anomalous cases. If I go to the transform menu and I come down to prepare data for modelings, this is the automated data preparation feature that I was talking about. I also mentioned feature selection. So if I go to the Analyze menu and I come down to dimension reduction, predictor selection is feature selection. Remember, this is a procedure that will take a number of fields and narrow the fields down. So it will show you the fields that are useful in a machine learning model. Above this, we have classify, and here we have cluster analysis. So these are unsupervised machine learning algorithms. We have density-based clustering here. We also have decision trees, and we have neural networks. So decision trees and neural networks are supervised machine learning algorithms. So they're focused on finding information about a target. So we want to predict a target using a number of fields. So now I'm looking at a syntax file. And to get started, I wanted to show you what's in this syntax file. So at the top, we have a simple custom table. So this is a table showing percentage of products purchased. Now, we're going to go from this simple table to cluster analysis. And here we want to know what groups do we see in terms of products purchased. So are there hidden patterns that we are missing? Below this, we have predictor selection, also called feature selection. So we want to know what variables are associated with the subscription service. Now, I mentioned that feature selection is great because if I had many fields, I could potentially narrow down the fields that I would use in a machine learning model. Below that, we have a decision tree. And here we're predicting subscription service. Now, this is a decision tree using clusters. So I created the clusters, saved them in my data set, and then I want to use them in a further analysis. And this is a decision tree. And below that, I have a neural network model. So the first thing I'm going to do is go to the Run menu and select Run All. So here we have a very simple custom table, and we can see the percent purchase. So we see that 53% of our customers bought ready-made foods, 44% bought frozen foods, 39% bought alcohol. Down here, we can see that 3% bought fresh meat. But when we start to look at this, it doesn't really tell us anything. Now, below that, we have cluster analysis. Cluster analysis is an unsupervised machine learning algorithm. It's going to help us find hidden patterns in the data. So I'm going to scroll down. Now, keeping in mind that very simple table we were looking at, we're going to go into the final cluster centers table, highlight the cells, ask for 2 decimals, and create a bar graph. Now, let's have a look at this because what we see is clusters, clearly defined groups. Have a look at cluster 2. 84% by ready-made, 81% by frozen foods, 76% by alcohol. And then we look down, we see 90% by bakery goods, 74% by snacks, 82% by tin goods. When you look at cluster 2, you can see they're buying a lot of everything. If you look at cluster 3, by contrast, you can see they're buying ready-made meals and fresh vegetables. When you look at cluster 4, it's ready-made, alcohol, and then here bakery goods, and here tinned goods. So working with your domain expertise or the domain expertise of the customer you're working with, we could label these clusters. Cluster 2 could be a big shop because they're buying a lot of products. Cluster 3 could be food for tonight because it's ready meals and fresh vegetables. Cluster 4 could be a convenience cluster. Cluster 1 could be pantry staples. So we can save this cluster solution and we can name these clusters. Now, the next thing is select predictors. This is feature selection. So I have my cluster analysis. I have my cluster solution. I've saved it in the data set. And now I'm also looking to understand what's associated with customers taking up a subscription delivery service. Now, I can come down and I can see the predictor summary table, and I can see the selected predictors. What SPSS does is it looks at each predictor and looks at how the data is typed, and then it looks at your target. In this case, do they take up the subscription service? And then given how the data is typed, it will choose the appropriate statistical test. These tests are run in isolation. That's why we have unadjusted significance. But again, this is a guide. And it ranks the fields. So at the top of the list, we have fresh vegetables, followed by ready-made, followed by children, bakery goods. Do they buy milk? Do they buy frozen foods? Are they working? And so on. So the feature selection, the predictor summary can narrow down the fields that come into the model. Below this, I have a decision tree. Now, I use this decision tree to understand who takes up the subscription service. And if you come down, you will see that I have a gains for nodes table here. So node 24, node 41. And you will see that we have a training data set and a testing data set. So with the machine learning algorithms, it will split the data out. So it will randomly split the data into a larger training data set, build the model on that training data set, and then test it on the holdout data set. So that gives us even more confidence in our model. But if we look at node 24, you can see the response rate, 96.5% took up the subscription service. And if we just click in here, Now what I'm going to do is widen this out. I want ranges as text. And then if we go back in and we have a look, we can see that if we look at those who are, for example, food for tonight, 80% take up the subscription service. But then if we look over here, if they're older than 40, you can see 87% take up the subscription service. So you can see that here. And then if we look at divorced, married, and single, you can see that 96% take up the subscription service. So this particular node, they're divorced, married, or single, they're older than 40, and they're in the food for tonight category. These individuals are very likely to take up our subscription service. So we can go through the decision tree and we can learn things and we can see subgroups within our customers. We can see those that are very likely to take up this subscription service. Let me close out of my output. Now below this, we have our neural network output. Just scroll down. You can see it gives me accuracy in the training and in the testing. So you can see the model is 84.4% accurate in the training and 84.5% accurate in the testing data set. Now we are testing on a historical data set, so it's going to give me accuracy for how good this model is in finding those who are likely to take up the subscription. And then we can see the importance of each variable. Now, if I go back and we talk about training and testing, because we saw that in the decision tree, we see this in the neural network model. So we have a historical data set, but how do we score cases where we don't know the outcome? So let me show you how to do that. So I'm going to open up a file called New Cases. Now in this file, we don't know the outcome, but I want to apply one of the models that I've built. So I'm going to apply a decision tree model. To do that, I'm going to go on the Utilities menu, go to the Scoring Wizard. I've selected the tree model, so I save that model that we looked at. I'll click on Next. I can see the fields. I'll click on Next. And then I need to select the probability of the selected category. Click on Next. And I want to score the active data set. And what this gives me is a probability. So you can see, I'll be able to see, in this case, customers that are very likely to take up the subscription service. So the first data set we analyzed, we already knew the answer. That's historical data. This is a data set where we don't know the outcome. And actually, we can apply a model to give us a likelihood, a probability associated with that customer taking up the subscription service. So now I have new cases. I don't know the outcome, but I want to use one of the models that I've built. So what I'm going to do is go to the Utilities menu here and come down to the Scoring Wizard. I'll select my model. I'll click on Next. I can see the fields. And then I want to select the probability of the selected category. I can score the active data set or I can paste it. I'm just going to click on Finish. And now you can see that it gives me a selected probability, a model prediction, and you can see the node number in the tree. But most importantly, the probability is going to be very useful for me. But you can see it's easy enough to score up new cases using a model that you've built. So we started this webinar with giving you pointers on what makes a good data analyst. But I think now in the age of AI, it's important to use innovative approaches with your data and change your analytical tools. You want to simplify data complexity by exploring tools and methods that enhance clarity, can streamline your task, minimize errors. So you want to think about the tools that make preparing data, analyzing data, understanding your data a bit easier. You also want to commit to ongoing learning. So you're regularly seeking new skills and new tools and assessing how they can improve your work. You also, I think, can serve as an innovation lead for your organization. You know the data very well. You'll also know the business environment very well. So you can show others the value of the knowledge that you have and the data that you manage. And you can educate them about the tools and procedures that you are using. Now, as a summary, we covered automation tools. So I showed you where anomaly detection was in IBM SVSS statistics. I showed you where automated data preparation was. We ran a feature selection procedure. Also, automation of syntax, don't forget about paste. Now, in using these tools, as I said before, you are in charge of evaluating the results from these. And of course, you will use your domain expertise to know how to run these and how to evaluate the output. We looked at some machine learning algorithms, and these provide insight, and they also allow us the use of many variables. So if you think about the machine learning algorithms which learn from the data, we ran an unsupervised algorithm. This was cluster analysis, and we found hidden patterns. We found groups of customers that bought certain products. We also ran decision trees and a neural net model, and we used these to predict the take up of a subscription service. Now, with the integration of AI, data analysts can enhance their toolkit. And of course, you can develop robust models that will facilitate actionable insights. Again, using machine learning, you will evaluate the results from machine learning models coupled with your domain expertise. Of course, you'll learn and know how to run these machine learning algorithms and how to evaluate the output. So that's everything we wanted to show you today. If you want more information, you can go to our website at www.sbssanalyticspartner.com. So thanks for watching and bye for now.